Okay, Assalamualaikum and very good evening. So today we will like to presenting about our team presentation, which is regarding about projectile motion for our subject, which is dynamic mechanic and machines. So at first, I would like to introduce myself. At first, my name is Ahmad Danish bin Musafasha. My matrix number is B1434100197. So we will go into the introduction. Okay, for introduction, let's go. Okay, for introduction of projectile motion is a curved path an object follows when it's thrown or launched into the air and move under influence of gravity. Once the object is in motion, gravity pulls it downward while its initial speed carries it forward. These two effects combine to create a smooth, curved trajectory like when you throw a ball, and it goes up then down in an arc. This motion happens in two parts at the same time, horizontal for side to side and vertical up to down, and together they form to complete path of the projectile. Okay, we will going for the next slide, which is objective. For objective, here we go. For this assignment, there are three objectives for projectile motion learning. So the first one is to understand the concept of projectile motion and the factors that affect. This objective means learners will grasp the basic idea of what projectile motion is. The curved path followed by an object under the influence of gravity after it is projected. They will also recognize key factors that influence this motion, such as initial velocity, launch angle, gravity, and air resistance if considered. And the second one is to explore the motions of objects under the influence of gravity alone. Here, learners will focus on analyzing how objects behave when gravity is the only force acting on them after being launched. This helps them understand why projectile motion follows a specific curved path and how gravity pulls the object downward throughout its flights. The third one is to analyze the horizontal and vertical components of projectile motion. Learners will break down the motion into the two parts, the horizontal motion, which is stay constant, and the vertical motion which change due to the gravity. Understanding how these two components work together helps in predicting the objective overall path or trajectory. So that's all for my slides. I will give this presentation to my other friends. Thank you.
And hello, my name is Muhammad Aziz bin Zakanai, and I would like to show about our group mechanisms of catapult. There are 5 parts important in our catapult. The first one is frame. Frame used to hold the structure together. We design our frame in pyramid shape because it used to keep everything stable since the triangle shape distribute force evenly and resist deformation. And the second one is pivot point. Pivot point were as a fulcrum for the catapult, so it made us more easily to aim to our target. And the third one is rubber bands. Rubber bands used to store and release energy during launching process. And the fourth one is levered arm. Lever arm used to launch projectile while the rubber bands release the energy. And the last one is projectile holder. Projectile holder used to hold the projectile from falling.
Hi, my name is Farinayan bin Hamdan, and I will explain the relation between the catapult that we built with dynamic and mechanic of machine subject. Without further ado, let's jump right into it. So first of all here, this is our free body diagram, and as you can see here, this is where our ball started, this is where we launch our ball, and this is the VO, this is the X and Y axis here, the vertical and horizontal motion, and the distance is 1 meter. This is according to the assignment that we got assigned to by our lecturer, and this is the height that we found when we doing the launching process. So the relation between this with dynamic mechanic and machine learning is here. So first of all, we know there is a small deformation that will happen. So when the lever arm got pulled, there will be a small deformation, which there's gonna be force, right, when we pull the catapult down. So the force is, the force required follows Hooke's law, which is, we all know, Hooke's law is force equal to the spring constant, or in this case, the rubber band's constant, because it works the same way. And X is the length of the rubber bands. Okay, and at the same time, the rubber bands store potential energy, which is U. So when we put force, this is before the launching process. This is when we pulling the lever arm. So when we pull it with the force, the rubber bands will absorb energy, and that is potential energy here. Next is this is during the launching process. So when the rubber release the launch, when we release the rubber, or we release the lever arm, the lever arm will be pulled forward because our catapult works like this. Like the rubber bands will pull the lever arm, and that thing will create torque, which is force multiplied with radius. And the lever arm's rotation converts torque energy into projectile's kinetic energy. So when the projectile got launched, or in this case we are using ping pong ball, so when it got launched, there will be kinetic energy because that thing is moving, right? So there will be kinetic energy there. So this is kinetic energy formula, as we can see here. And then here is the thing that we're gonna find in this experiment. So first of all, during launching, we can find vertical motion. So vertical motion is y-axis. So this is the formula that we need to use to find y-axis here. The reason why we are using g, because we don't know the acceleration, so we are using the gravity constant, which is 9.81. And then this is the horizontal motion, which is the x-axis when we are launching the projectile. So again, we are using the gravity constant, or the gravity acceleration here, but we just change it to x because it's horizontal. And then finally, the spring, or the rubber bands, in this case, stiffness, which is K. So we need to find the K, like the Hooke's law, force equal to Kx, or K multiplied with the rubber band's length. So in this case, we are trying to find the K. So we are using this formula here, which is, this is the potential energy formula, and this is, and the other one, the another one is kinetic energy formula. So we are we're gonna equal it to find the rubber band stiffness here. So for the next part of this presentation, I'm gonna pass it to my teammates. Thank you so much. Precise. Tadi okey lah sikit kan. So tangan kita aku rasa.
Assalamualaikum, my name is Muhammad Nazir bin Abdul Latif and I will continue with the calculation. To start off, we will calculate the horizontal motion using the formula x equals to x naught plus v naught times t. X is the distance the ball will land, which is 1, equals to x naught, which is the initial distance, which is 0, plus v naught, which will be v naught cos 18.68 degree, because v naught is at an angle while we are finding the horizontal, and then the t is time. And inputting all the numbers, we will get t equals to 1 over 0.9473 v naught, which will be named as equation 1. Moving on, we will continue with the calculation of the vertical motion using the formula y equals to y naught plus v naught times t plus 1 over 2 times g times t to the power of 2. The y is the height the ball will land, which is 0. Y naught is the initial height of the ball, which is 0.124 meters, plus V naught, which will be V naught sin 18.68 degree, because as earlier stated, the V naught is at an angle while we want to find the vertical of the velocity, times t, which is time, plus 1 over 2 times g, which is negative 9.81 meter per second, times t to the power of 2. And we will get 0 equals to 0.124 plus 0.3203 v naught t minus 4.905 t to the power of 2, which will be named as equation 2. Moving on, we will substitute value of t from equation 1 earlier into equation 2. We will get 0.124 plus 0.3203 v naught, and the t will be 1 over 0.9473 v naught minus 4.905 times 1 over 0.9473 v naught to the power of 2. And doing all the calculation, we will get the velocity, which will be 3.4392 meter per second. And with this, we can calculate the time with the equation 1 earlier. T equals to 1 over 0.9473 v naught. We will get the t, which is 0.3069 seconds. And then we can also calculate the spring stiffness k. The formula is 1 over 2 k s to the power of 2 equals to 1 over 2 m v naught to the power of 2. The k is the spring stiffness, the s is the distance the spring is pulled, or the change of the length of the spring, and the m is the mass of the ping pong ball, and v is the velocity of the ball. And by inputting all the values that is known, we will get the spring stiffness k, which will be 37.85 Newton per meter.
Assalamualaikum and hello, my name is Muhammad Lazuddin and I will be continuing with the conclusion. In conclusion, the experiment successfully demonstrated the principles of projectile motion. By applying kinematic equations and adjusting the launch angle and force, we achieved consistent results that align closely with theoretical predictions. The project emphasized the importance of precise measurements and design in achieving accurate projectile trajectories. Overall, the experiment reinforced key dynamics concept and showcased their practical application in mechanical system designs. That is all from us. Thank you.